Hello and welcome to the first in a series of flipped classroom presentations for AP Chemistry. I wanted to start off the first in this series with, perhaps fittingly, a little review of the kinds of problems that you're going to be facing on next week's test. And the test, of course, is mainly on things that you learned how to do in earlier chemistry courses, but kind of presented in an AP fashion. So they'll be a little bit more challenging, perhaps, than what you've seen, but usually the challenge for students isn't so much the material, but the nature of how to show the kinds of work that require your documentation of every single step. The College Board will not give you full credit unless you've shown sufficient work, and so unless you show kind of all your work, you're not going to get much credit. Most problems on the AP test are worth either 0, 1, not 0, 1, 2, or 3 points, and mistakes like these tend to cost you at least one, if not all of those points. So any little mistake in terms of leaving out a key step is going to cost you anywhere from 33% to 100% of the problem. So the best you're going to do when you start making these kinds of mistakes is at the D+ level. So they're pretty catastrophic, and of course they tend to be on this test for me as well. I think it's pretty beneficial, unfortunately for you guys to learn that pretty rapidly, that if you make these kinds of mistakes, the punishments are rather severe, and that tends to fix the problem, at least for many students, pretty quickly. Some of them seem to hang on to their point-losing ways throughout the year. So I wanted to kind of look at a typical couple of problems that you might encounter on the first test, with our first example here being an empirical formula problem, with something being the empirical formula given percent compositions. And you're probably now familiar with the percent to mass, mass to mole, divide by small, multiply to whole phrase. But the problem, of course, is that that doesn't tend to tell you how to do those things. And so students tend to just launch into showing some of their work, but not really all of it. And I think a lot of you, especially given that these problems are pretty comfortable and pretty familiar, can do a lot of this on your calculator and then sort of jot down some rough documentation of the kinds of answers you were getting, but not necessarily the work that led to those answers. So if we look at this example, for instance, you'll see that this student, which is actually me, which you'll be able to tell by the terrible handwriting, has gone from percentages to masses pretty much directly. That's actually okay. That's not a big problem. That's a pretty acceptable thing. That's not a problem. But then they've gone from grams to moles without showing any work at all. So this step is not okay. You'd obviously have to show the, divide by molar mass, which that's the kind of symbol for molar mass, the capital script M. So you'd have to show divide by that, and of course that would have to be in grams per mole. So you'd have to kind of document that, in grams per mole. And then you can see that once you arrive at moles, you divide by small. Well, this person has divided by small, but has not shown how to do that exactly. So this would be another situation where there'd be some problems. You'd have to divide by the 6.80, and that would get you some more credit to that. And then, of course, there's the as though we have all magically followed along with how to get there. There's no work being shown here, where you'd obviously have to multiply to a whole, in this case multiply by 3 to convert from C and H to whole numbers. C3H8 would be the final answer. So on the AP test, this would probably be a 2-point problem, and the student would have earned maybe 1 point. On my test, it might be worth 5 or 6 points, and the student might have earned 3 points out of 5, maybe 4 points out of 6, maybe 3 points out of 6, depends how generous I was feeling on my rubric. So certainly not full credit, even though the answer is correct and there's some documentation. It's simply not all there. Okay, in this next example, this would be another pretty similar type of problem to the first one, in that it's stoichiometry related. We're asked to find the number of hydrogen atoms in 4.21 grams of ethane, C2H6. There are a number of pitfalls for students that are overconfident or haven't really needed to show work in these types of problems before. Some of those places where students tend to leave key things out would certainly be in the how to get to moles. So a lot of students will just go from the 4.21 grams straight to moles, and you can't do that. You've got to show work to get there. I know it's easy. I've done it thousands of times, but but I still show my work because you guys need to learn to show your work, so please do so if you want full credit. If you don't, feel free not to. And then you get to the moles, and when you have moles C2H6, the most common thing at this point when you're here is for students simply to say times 6. You don't really get to do that in science. There have to be labels with what you're doing. I don't get to, on my income tax, simply write times 6 because I feel like it. You have to say why are you getting 6 for the price of 1. So we have 6 H's for every 1 C2H6. That's a very critical label. Without it, the problem loses a little bit of meaning and certainly is going to lose you credit. So you've got to indicate that there are 6 H's for every 1 C2H6. You could do that with some sort of ratio, like you put parentheses and put 6 H's colon 1 C2H6. It's not quite as elegant. It certainly doesn't flow in the course of the dimensional analysis, but it would probably be okay. It's just not really as nice as doing it in this particular way. Then we get the moles of H. And then from there we multiply by Avogadro's number. Again, a lot of times students simply multiply by the number 6.02 times 10 to the 23rd. That isn't, sort of the same ilk as multiplying by 6. It simply is 10 to the 23rd times greater in terms of the size of the error there. You can't really just multiply by Avogadro's number. You have to multiply by Avogadro's number relative to the units involved. In this case, that's atoms per mole. There are that number of atoms of H in every mole. And so we arrive at the correct answer having shown all the work that we would need. Again, on the AP test, this is maybe 1 point, possibly 2. And so not showing work here might actually cost you the entire problem. Certainly at the minimum, it's going to cost you 50% of the problem. So little silly errors, overconfidence, simply a lack of attention to detail, they're going to be very, very painful on this first test. So please be aware of that as you go. All right, and our final example for this first little flipped project on review and stoichiometry and primarily showing work. We'll probably do another one the next day or two on significant figures, so you can learn about that. This one will be about how to show the kind of work that you need to show to do a simple unit conversion. These are pretty common problems to be able to do in this first unit and really beyond, because you're going to have to do a lot of this at various points along the year, going from units like grams to moles, moles to molarity, molarity to via density to who knows what else, maybe molality. So you've got to learn to be able to manipulate units, show work along the way, and so this would be a question asking us to go from miles per hour to centimeters per second. So if something is going 15 miles an hour, how many centimeters is it traveling in a given second? So I've shown the conversions kind of one by one. I really prefer this kind of dimensional analysis. A lot of students come in trying to do these in a series of proportions, and I can tell you as a grader, that's a nightmare. If there's more than one conversion at a time, it really is not user-friendly to do it this way. So I would strongly recommend that you learn to do this kind of dimensional analysis technique. It is simply a much cleaner, more elegant, and quite frankly easier to grade method. And while this may seem somewhat subjective, when something is easier to grade, it's usually going to get a higher grade, especially come the AP test in May. The last thing the AP graders want to see is a bunch of garbage slapped on a page that's really hard to figure out. Remember, they're grading over 100,000 tests in 5 days. So if you've made your work hard for them to grade, you've made your life more difficult too, because you're probably not going to get the benefit of the doubt at that point. So what I've simply done here is gone through the conversions of the units. Most of these would be provided for you if you need them. Maybe on the first test, I would expect that you would know how many seconds are in an hour. You probably don't know innately how many centimeters are in a foot. So you'll be given the necessary conversions, but I would simply assume that you know the simple ones like seconds and minutes and hours and inches and feet and centimeters and meters and millimeters and centimeters and millimeters and meters and that kind of thing. So we have 15 miles per hour. I converted that from hours into seconds. So we've got hours and hours canceling. And then that will leave us at miles per second. So then I got rid of miles by converting it to feet per second. And we now have a certain number of feet per second. And then when we do the final conversion, we get rid of feet and go to centimeters per second. Where did this 670 come from? Well, two places. One, I simply multiplied 15 times 5,280 times 30.48 and then divided by 3,600. I then rounded a little bit simply because the number of significant figures in our initial information was only 2. The 1 and the 5 are the only 2 digits of information we have, so I should really only be reporting 2 in my final answer. I know it does come out to about 671, but that 1 and 671 would be uncertain at best because our given information is simply not exact enough for us to say with confidence that at 671 centimeters per second, we would be more inclined to say it's about 670 centimeters per second. But that's a topic for another flipped discussion, probably tomorrow night or the night after. So hope you've enjoyed this one. Hope it proves helpful as you approach the test. And if you have any questions, please feel free to email me or simply find me at school.